Yeah, but sometimes for some students it's early. Okay. Today we will start to talk about the design patterns. And I will start with one of the easiest one and one of the representative of patterns. So you can, I hope you can see how patterns will work. So we have the problem, why we need a pattern for this. This is the iterator pattern, and later I will talk about the composite pattern. Okay, do you know what a collection is? No? Think about object-oriented programming. You have objects, and you have a set of objects. 10, 20, 100 of the same class. This is a collection of objects. And yes, you want to iterate over a set of collections, a set of objects. Iterate over a collection. How you can do that? You don't want to see the implementation of the set of objects. So this is a Java collections framework. Have you ever heard of it? No. Okay. So you have no idea what a vector is in Java or an abstract set? Yes. You have, I know, but you're not responsible. It's not important that you know it. It's for your students. I have to ask them if they know. I said, you know it, I know. Have you ever heard of it? You have, but you haven't.
It's kind of like an array.
Array is
a resizable array.
It's not on this collection. Array is very special. It's for linear algebra and things like that.
No,
computer graphics.
Not that array. Array is like a vector. Set of linear memory.
Array list you have in Java.
Okay.
Okay. This is how do you read this? You have interfaces. These are the small circles. You know the interface structure in Java? Okay. Then you have abstract classes. You know the difference between abstract class and interface?
I don't know much about Java.
You don't know a lot about Java. Okay. An interface is just supplying signatures of operations. And an abstract class can also implement an implementation of these operations. But, because it's abstract, you cannot get objects from it. Abstract class is just a little bit more than an interface. It has implementations of the operations. Then you have real classes. Real classes, you can see, are don't have the word abstract, but that is not the point. You see the kind of the parabola is different written, and then the word is different written as this one. It is, we call it cursive.
Italic.
Italic? Okay. So the difference in UML diagrams between an abstract class and a class is that you can see that the word is written in italic. It is, I think it's a very bad solution, because you have to look very carefully whether it's abstract or not. Can you see some abstract class, some abstract and some real classes? Give some example. It's an abstract and that is a real one.
Priority queue is a real one.
Priority queue is a real one, yes.
An abstract collection is
abstract.
Not real.
It's very easy because all abstract classes start with the word abstract, but that is not necessary. So this is just for mnemotechnic reasons. difference, the real difference in UML is that it's just written in italic. Okay, do you know this? The meaning of this file, the meaning of this arrow?
Inheritance.
Inheritance. Generalization, specialization. We have others. These things here. It's the implement. Because interfaces, between interfaces can have inheritance, but an interface is implemented by a class, abstract or not abstract. Okay? So that's an ordinary UML diagram, and if you know UML, you can do it. Okay, this Java collections framework was developed over all the time. It started with a vector stack, and somewhere here was it's gone. Vector and stack, and over the years they added more and more of these interfaces and abstract classes and classes for the programmers that they can get appropriate internal representation of the collection of elements. So, I said, you do not want to see the implementation while iterating over a collection. Means, independently, whether it's a vector, it's an array linked list, it's a priority queue, or preset, you want to iterate over the number of elements without knowing what it is. That's the idea of an iterator. You don't have to think about, oh, this is a set, I have to do different implementation because it's a set compared to a vector. So let's look at the typical elements of this structure, of the this pattern. You have two interfaces and two concrete implementations. You have an interface collection and an interface iterator. The iterator has two operations. It has a next operation and it has a next. So, has next means it's asking, is there another element available? And the answer can be true or false. If true, you have the possibility to execute the next operation without getting the answer, there is no element left. So, the interface iterator defines this interface for traversing the elements of the collection. The concrete iterator is, because this is an interface, has to implement these two methods. So maybe we have different concrete implementations for a set, a list, an array, or whatever you have, but because you're using the interface as a programmer, it doesn't matter what implementation is behind. It always has next operation, and how it is implemented is not interesting for you. If you execute has next, it gives you the answer, there is one or not. And how it is implemented, according to set, linked list, or whatever, it's not your problem. That's the trick. So you can use the iterator independently of how the elements are organized. Here you have the interface collection. It's an interface that is generating an object of the class iterator. Of this one. And the concrete collection is implementing the operation, the complete operation, the iterator operation, the creating of the iterator operation. Okay, in Java, we had what is called cursors, that there are different cursors. Java started when it was born with a cursor called enumeration, and it was a long time when it was available. I think it's not available anymore. And if it's available, you should not use it anymore, because they found out that it was not a very good implementation. So they, in Java 1.2, they implemented this iterator and also list iterator operation. We look at this one because this is already available, it's already good, and it's working. And it's not deprecated. You cannot expect that it's, you know, the word deprecated. They kick things out of them. So you have to be careful if you do things like that, because your system has to modify it. They really kick it out. Okay, interface enumeration, I will not tell you a lot about that, just for historical reasons, because some of my students used it all the time, and I said to them, no, don't do it anymore, because it's implemented to hash table, to vector and stack, and these collections will not be supported very long. So, but you will still find it in books. But you should not use it anymore. The iterator interface has what we have already seen. It has next operation, it has the next, and it has the operation that you can remove an element. Okay? It is implemented by all collection classes, interfaces and classes. We have the maps structure in Java. It's key value pairs. So there's a little bit different. We have method values. But we stay on these classical collections, and there you have it. Okay, let's look how it works. You have some objects. Here they are ordered. We don't know how they are ordered, because we don't know the structure which is behind it. It could be a set, array, it could be tree set, we don't know. So, at the beginning we are looking at no element, then we are executing the operation as next. And we get the information, yes, there is one. And then we say next. So what is happening? We have a pointer that points at the first element. Yeah? The idea is we want to traverse the whole group of elements. Let's look at the group of students who have taken part in Professor Poser's course, computer graphics. He wrote an exam, and he wants to know what was the average of the marks. So what does he have to do? He has to count all the marks and at the end divide it by the number of participants. So what have you to do? You have to traverse all these elements. Okay? So after we have the first element, we read your mark. It's, let's say, a very good one. In Germany, it's 1.5, let's say. So we say it has next. Yes, there is another one. So we can go there and we have the pointer now to the second element. And we can read your marks, good as well. So we add that and ask the question, has next? Yes, there's another one. We can go there. And we do that plenty of times. Okay? At the end, we come to the last element. And if we ask here, the question has next, now the answer is not right, true, the answer is false. So now we know we have traversed all the elements. You look so strange. Do you believe me? Okay. The answer is false, so what does it mean? We have no more elements. so we can finish this traversal of the elements. What is really important is that you see, it looks very simple. The trick is just that you have no knowledge about the internal structure of these elements. It's not necessary. That's the point. So at the end we have and go to the last, and there is nothing. So if we look, we can move from one element to the next till there's no one anymore. We have to realize that this structure is only traversing in a forward manner. Well, if you have to traverse all elements, then it doesn't make no difference if you do it forward or backwards. And the only interesting thing is that you don't jump around. You just have to move straight forward. So, turn left. Okay, this is a different. I've implemented a hash set, and you can traverse through the hash set without knowing it's a hash set. An example. Next time you say write tree set, and you can traverse as well. The structure of the collection is not important for using the iterator. That's very easy pattern, and it's implemented in Java quite well. And we have now in modern programming languages that this iterator is much better implemented. So you just say, give me the next, and you just give you the next, more declarative programming. So there's still iterator in it, but you don't see even the iterator anymore. In Ruby, or for example. Have you used ever Ruby? Okay. The newer programming language, I think Python is the same, don't have this iterator structure. They have it inside, but you don't see it anymore. It's just one more level abstract. Okay, so what I try to explain to you is this, that patterns address a special problem, and they give a solution. We don't know it's the best, we know it's a good one. And everyone is using it, and unless no one found a better one, we say, okay, this is quite good, we can use it. We know it's good, we know it works, and we gave him a name, it's called iterator, and we can use it in Java and C++ and Smalltalk. More modern languages have better or other implementation. Okay, now you have an idea what a pattern is, or can be. I hope so. Now let's take a look at the world of patterns, of design patterns. So we will give you a definition. What is a design pattern? Without the name software, then what is a software design pattern? Then I tell you a little bit of the classifications of software design patterns. And at the end, I will tell you how they are documented. We have rules of how to document a design pattern. Yes. all the pictures I have of people are pictures of old men. This is an architect, not a software developer. It's called Christopher Alexander. And he was the father of the pattern idea. But not for software, but for buildings. He said, yes, we do build houses and skyscrapers and bridges and all these stuff. All houses have a similar idea of how to live in. Yeah. And you can describe what is a good solution, for example, for a sleeping room, for a living room, or for a kitchen. Yeah? For a kitchen, you have to try that you don't run around too much, that everything you need while you cook is close to where you are standing. So we set pattern in architecture is the idea of capturing architectural design ideas as archetypal and reusable descriptions. So, definitions I read from the end. We have reusable descriptions. So the description of something we can reuse all the time. And is an architectural design idea. It's an idea, an architect, an idea how we have something we can reuse in architecture. So he was born in Vienna in bad times, 1936, during the Nazis, and he left 38 when he was 2 years with his parents to England, because his father was Catholic, his mother was Jewish, so it was very dangerous for them to remain in Vienna, because the Nazis, as you remember, killed millions of Jews. So he went to California, and he had this idea. He was a professor of architecture, and he was the describer of this pattern idea. This pattern idea was not so successful in architecture. But in the 90s, when we moved into software, it was absolutely, it was a wonderful thing. And why is it? Okay, it is because architects and software developers think different about their problems. If you're an architect, you want to have a building which is different from all the other buildings. You want that people see that it's designed by you. So you have to do different designs. As if you look at the skyscrapers, modern skyscrapers, okay, you say it's just a building rising up in the hill. But if you look very carefully, you see that these good architects have very good ideas how it looks. Different looks of skyscrapers. They are cheap. The cheap ones are all looking the same, but if you have a good architect, he's designing different type of skyscrapers. You see that it's a good idea what he did. So the idea of pattern, doing all the time all the same, is contrary to how architects try to live and to build houses and skyscrapers. For ordinary houses, it may work, but if you have a amount of money, you want to buy a parliament, a skyscraper, a railway station, then you want to have an individual solution. So architects try to generate individual solutions. In software development is completely different. We are very happy if we have a solution for something which is already there, because no one sees our solution. No one is going to you and say, oh, that's a well-developed design pattern. Maybe someone has to modify your code, you would say, but the customer will not say, oh, what a beautiful design pattern you implemented. The customer is satisfied because it works, not how it works. Completely different to architects or car building, car designing, where you have to see a different cars that has to be different from other cars. If your programs look the same and they do work well, great. So we were happy with this idea. quite very happy. Yeah, we had a software design pattern as a general, reusable solution to commonly occurring problem within a given context in software design. So we have this problem in software design, like the iterator pattern. We have a solution for it, and it's great that you use it, I do use it, and Caesar do use it as well. And no one will say, you're all having the same solution, that's boring. Everyone will say, you all have the same working solution, that's great. That is the difference. Yes. So the point was that when in 1995, the four computer scientists collected, they just collected and had a common description, collected 23 design patterns. I tell you, 2 or 3 years later, every software developer had this book on his table. Because it was such an advance in programming of these special problems that everyone bought this book and had to use this pattern. So it was a great improvement in the solution of special small problems. We will see other problems in some minutes. So we have always to think that it's not a finished design. It's not ready. You cannot take it and with cut and paste it into your code. You still have to do something with it. But it's because first you have not to think about the solution, because the solution is already there. You just have to implement it related to the problem you are just doing. That's really good. It's a description or template for how to solve a problem that can be used in many different situations. As I said, if we all use the iterator pattern or the observer pattern, and we all do it right, it's great. No one will say you use the same solution as your neighbor. It's good. We like it. Yes, design patterns are formalized best practices that the programmer can use to solve common problems when designing an application or system. So it's not, we say it's best practice, but we do know whether it's the best solution. Maybe there's existing a better one. It's not in the mathematical sense the best solution to something, but it's a very good one. So that in the 95, this book was published, and after that, within 5 years, hundreds of patterns were published, in addition to the 23 in this book. So they sorted it a little bit. There are creational patterns who think about how to create objects, where to create objects, when to create objects. Second is structural, how to structure something in the code. We have some classes, how do they relate to each other? What is their typical relation for this code? Behavioral, how they work, like the iterator pattern. And there are concurrency patterns, messaging patterns, or object relational mapping patterns. There are architecture patterns as well. I put it into, how do you call it? Klammern, German. How do you call them? Parentheses. And some other groups. I have to put this in parentheses because this is not the design pattern, it's an architecture pattern. So I just collected well-known patterns, creational design patterns. On the left side are always the well-known design patterns from the book. Software design patterns in 1994, 5. The singleton factory method, the abstract factory builder, and the prototype. We have other equational design patterns, single factory, multi-tone, dependency injection, lazy initialization, object pool, and resource acquisition initialization. These are later published and are used in some contexts. Too much. Okay, here we have the structural design patterns. On the left side is the patterns from the book: adapter, composite, decorator, facade, bridge, lightweight, and proxy. On the right hand side, the design patterns later published, but also important: delegation, extension object, from controller, marker, module, and trim. The behavioral design patterns: it's the command, the iterator, the observer, the state, the strategy, the temperament, the visitor, the chain of responsibility, the interpreter, the mediator, and the memento. And not from the gang of four, blackboard, null object, servant, specification, and fluent interface. Blackboard is, from my point of view, more an architectural pattern than a design pattern. But we can talk about that. So I cannot tell you every pattern, because then it starts to get boring. Just another pattern, and another, and another, and another. So I will talk about some of them.
There is no overlap between them.
No overlap.
Overlap.
Mm.
Maybe I have to use this one or this one. I don't know.
No.
It's very clear.
There, I would say from on the left side, I'm sure it's very clear. Special problem, special pattern. From the right hand side, I have to look. No, very clear. Here it's not so. I'm not sure. Maybe delegation and front controller have some overlapping. It's one on the left hand side. The simple factory is a very, very simple starting point to understand how factory method and abstract factory do work. Singleton and multiton is similar but different in a way that a singleton is a pattern where you have to generate only one object from the class. Yeah?
That's the only one that I know.
Yeah, of course you know. You will also know the factory method, I'm sure. You have seen, yes, maybe you use it without knowing it.
I just use singleton.
Of course, singleton is yes. Because sometimes you have a system where from one class you will have generate only one object. If you get a second one, it's wrong. Now let's talk about our university. We have a university system, and inside the university system is a class UFSM, the university itself. But this university does exist only once. So you would say I have to implement a singleton, because it's not allowed to create a second University Federal de Santa Maria object. Okay, I will not talk about concurrency design patterns, because it's more into real-time programming. But you see plenty of patterns. What I want to tell you with this slide is that if you do work and you have to program, and you have a problem with some classes in a special context, before you think too much about a solution, try to look, maybe there's already a solution available. You see plenty of different ideas how to solve special problems in the concurrency area. Okay, I'll come to that later. Okay, here's how do we document patterns? And I will just talk about some of it. First, very important, each pattern does need a name. When I say, okay, you please implement the iterator pattern, then we talk about the same thing, about the iterator, or the observer, another, or single. So with a name is associated a special behavior, a special amount of code you have to implement. So it's, for us, it's like a language. It's a new word in our language as a computer scientist. Yeah, you can go to your colleague and say, this is bad programming, just do it the other way. Or you can say, okay, I see it. Why didn't you implement the iterator pattern? It's quite different. Because if you say, why not the iterator pattern? You have a special idea how to solve this problem. And it's not so that you say, this is boring programming, what you did. So it helps to communicate with maybe colleagues who are not familiar with that. Pattern, name, very good. Classification, I already said, it's equational or behavioral or something. Then here you have some patterns in the beginning had different names. So there was one pattern, but it had different names. The iterator pattern also was described as cursor pattern. Today, some people still know that cursor is the same as iterator, but in reality, everyone uses the name iterator, not cursor. So you have a motivation, why does this pattern exist? You have an applicability, which are the situations in which this pattern is usable. You have a structure of the pattern. In reality, you have a UML class diagram or two, and you have a group of participants. Who are the classes and the objects used in the pattern and the roles in the design? And so on, you can, which classes do they collaborate? What consequences does it have if you implement this pattern? What side effects can you expect? Then you have an example of an implementation and the code of it. And sometimes you can say, okay, I know this pattern was implemented there and there and there. And you have patterns related to the pattern you already described. That is relationship with other patterns. Some patterns work very well together. If you have a special situation, you can put two patterns together. Yes, except to you, today is the day of old man, old white man. This is a Norwegian one. It's Prof, and he created an architectural pattern, one of the most influential architectural patterns in the world. I'm sure in your hand mobile, in your PC, and all the software you use, hundreds of model view controller patterns are implemented. It is so a basic pattern, you know it, I'm sure. You know, you will see, you will know it. And in the 90s, 70s, when I started to study, he created this pattern while he was working on the Smalltalk 79 version. What did he want? He wanted a pattern that could be used to structure any program where users interact with a large, convoluted data set. So, my question is, what is exactly the problem he tried to solve? What is the problem? Can think about this. User wants to interact with large data sets. First, we had an interactive system. The user sitting in front of the computer and try to interact, like the young lady is trying to interact with a mobile. So, in this situation, you have special ways to interact. We call it human-computer interaction, and we have a lot of done a lot of research. But his idea was very, very simple. A very, very simple idea. He created 3 topics. One is the model, MVC, Model View Controller. So the model itself is here in the middle. A model is something, is the data and the main operations of the data. So here you have an election, and this election means part Bolsonaro got 50%, Lula got 30%, and another candidate got 20%. Doesn't matter. We can change, if you like, we can change Lula got 50% and Bolsonaro got 30% and another guy got 20%. Doesn't matter. So this is data, and during the evening, this data does change. Yes. New results come in, and they're producing a different set. So the model receives user input from the controller, and the controller modifies the model. So now Lula got 48 and Bolsonaro got 52. So what is happening? It's modified. Yeah? The model is the data and the main operations. Views are representations of this data. So you see this data here, 50, 30, 20, is represented in 3 different ways. It's a cake, these are columns, and this is just data. It's the same data and you have different views. If the data is changing, the views have to change as well. So you have the model, which is data and main operations on it. You have the views, visual representations of the data. And the last thing is the controller. The controller is the one who is modifying the model. Okay, so this very simple idea how to structure a system. But as we all know, the KISS principle is very relevant. Good solutions always are simple. And this was a fantastic solution. They implemented it into the Smalltalk language, and okay, Smalltalk disappeared mostly now, but in the 80s we saw that maybe Smalltalk will be the main programming language just because of this structure. I was working with Daimler-Benz and we had a lot of information systems, and exactly these problems which arise in modifying data, in visualizing the data, is an ordinary problem of all information systems. The football club is playing on Saturday, and during the game the result is always updated if another goal is scored. Classical information system. Someone sits and updates the data. Gremio 2, Inter 0. Or the other way around, Caesar. And then it has to be sent to everyone who wants to know it. So we have a typical sequence of actions. The user uses the controller to manipulate the model. Then the model updates one view, all views, and the user can see the update. So this was so basic that today, if you look around, you will have 20 modifications of this model, depending on where you are working. Microsoft has a version, it's called Model View Model. It's just a modification of the Model View controller. can say any good programmed information system is using the model view controller architecture. What are the advantages of these model view controller patterns? Independence of presentation and data. Presentation and the data is independent, and we can have multiple views on one model simultaneously. As you have seen, data can be represented in different ways. We have composable presentation widgets. For example, one view is used as a subview of another. We have switchable input mules by swapping one controller out for another during runtime. You can change the controllers. And independence of input and output processing is a separate responsibility of controllers and views. Over the years, there was one simplification, unfortunately, one simplification of this model, which is used very much, and the advantage is that you are quicker while you develop the system. The disadvantage is when you have to modify it later, it makes more problems. The people do put a view and a controller together in one class. And then you call it document view. I don't know why. The document is the model, and the view is now the model and the controller together. So it's a simplification of this model. And it's done, if you have a small system, small information system, okay, just do it. But if you have large information systems who will live very long, don't do it. It's a simplification which is not, should not prefer. Okay, now we have now we can talk about how an architectural pattern and a design pattern are related to each other. Because a typical problem is arising here. And for this typical problem, a design pattern is a solution. What is the typical problem? The typical problem is, okay, the controller is modifying the model. So the model has changed. And now we have here 3 views. But if you have a world championship in football, 100 million people will look how Brazil played against Germany. It's Sitio Uno, I can tell you. I have to tell you the story. Caesar was my guest, especially on that day in Germany. And we saw the game together. It was okay. So, 1 million users have to be informed that the model has changed. And then you have 2 possible solutions for it. And you must know both solutions for this problem. The first solution is, okay, precondition is that the model knows all its views. It has a list of views. So the model has to inform 100 million people about the new result of the game Brazil against Germany. It has a list of all these 100 million people expecting the new result. Then it can do 2 things. It can send them a message, everyone, I have changed, and nothing more. It's a very short message. Then the views decide by themselves, by itself, do I need this information? For example, you can tell your mobile, I don't want to inform all the time. It's just necessary to tell me every 10 minutes something has changed. So you get the message, something has changed, and your mobile decides after 10 minutes, I want the information. So to get the changed information is in the responsibility of the view. The second solution is the model is sending the information to the views. So it's sending all 100 million people who are observing the model the new result. Okay, in this special case, you would say you send everyone the new result directly. But sometimes the model is changing and it's a large amount of data you have to send. And you have plenty of people who want to get this information. Sometimes it's an advantage not to send all information directly to the views. It's a better solution to send all the information I have changed. And if you want to change, I can send it. Famous book, The Gang of Four. Everyone is telling them the Gang of Four. I don't know why. 4 people that are called Gamma, L, Johnson, and Mercedes. And it's 1995. It's this landmark book design. 23 design patterns. It's in English. It's in German. It's in maybe it's in Portuguese as well because it was so important. I've already told you that. Here are the class diagram of the observer pattern. The information between the model and the views are best realized by implementing the so-called observer pattern. And you have an observer, it's called abstract subject, and you have plenty of observers to one subject or model. So, what operations does the subject have? It has the operation attach observers. So, an observer will be attached to the list of all observers. And you can detach. You can attach and say, I want to know how is the game between Brazil and Germany. And you can say, oh, I'm not interested anymore after it was 7-0. You say, oh no, I don't need any more information. Okay. So, at the end, a subject, this is a concrete subject, has a list of all observers. That is always happening. That has nothing to do with the concrete information of the observers. So, if the subject is changing set state, the new state, then the notify operation is executed. For all observers, they get the update operation will be executed. The update operation of each observer. What can we see, what can we not see in this, on this slide? We cannot see how the update operation is implemented. We cannot see whether the subject is sending all the information to every observer so that observers can do what they want to do, or if it's just sending the information I have updated, and the update operation is doing, deciding, well, I need the information, please give it. So, from this example, you can see that the architectural patterns cover the whole system. The whole system is designed according to model view controller. And all information systems in the world are designed to this pattern. Believe? You look. No, I don't believe it. Yes, you can do it. All this, in your hand, in your mobile, in your PC, all informations are designed an architectural version of model view control. Some are modifications of it, a little bit different, but the concept itself, it's all model view control. Everywhere. And it's a good solution because it works. The updates of the use are done by observers. Special part of the system where some classes are working together in a special manner. And to say I have implemented the observer pattern, now the architecture is fine, is wrong. Because the observer patterns usually cover a small area of your whole system. And you have hundreds of different implementations of observed design patterns in your system. You have hundreds 100 observers, 500 adapters, 20 facades. In large information systems, you have many, many, many designs. Maybe I have another thing. Okay. This is a sequence diagram. You know sequence diagrams from YouTube? Okay, just sequence diagrams shows examples of interactions between classes or objects, sorry, objects. Sample, this is just a sample of an interaction between objects. You have the subject, you have some observers. So the subject is executing the update method, or here is German is Benachrichtigung. Then it's sending to all observers the message aktualisiere, which means update yourself. And if we have another 20 here, then you have another 20 update calls. And it's well organized, you can never forget anything. It's quite fun. Okay, this is some solution for Java we have implemented in our lab room to see that our student can see how color is changing if you change the subject, which is just a recording of color, then you can add the color in different ways. It's close to the task of the task you have to solve. Okay. In English I'm a little bit quicker than I'm in German. So I want to stop the lecture and I want to ask you something about the project. Please, can you stop? Finish. Okay, thanks.